June 1944. The beaches of Normandy echo with the thunder of liberation. But behind the heroes storming Hitler's fortress Europe lies another battle. A battle fought not with bullets but with fuel. This is the story of the engineers who built the impossible. A pipeline beneath the English Channel that would change the course of World War II. In 1942, Allied commanders faced a mathematical nightmare. Every tank, every truck, every aircraft needed fuel to push into Nazi territory. Planners calculated that the invasion force would consume 1 million gallons per day. 1 million gallons every single day. Traditional supply methods using tanker ships and jerry cans would never be enough. German U-boats prowled the channel, turning supply vessels into floating coffins. Weather could ground operations for days, leaving armies stranded without fuel. Lord Louis Mountbatten, Chief of Combined Operations, knew they needed something radical, something that had never been attempted before. The idea came from a most unexpected source, an oil company engineer. His name was Arthur Hartley. Hartley worked for the Anglo-Iranian Oil Company, later known as British Petroleum. He proposed something that sounded like science fiction, a submarine pipeline. A steel artery running along the seabed from England to France, pumping fuel directly to the armies as they advanced inland. Military brass initially dismissed it as impossible fantasy, but Mountbatten saw potential. He gave the project a code name, PLUTO, Pipeline Under the Ocean, and he assembled a team of Britain's most brilliant engineers to make it real. Among those engineers was a man who would become the unsung hero of Operation PLUTO. His friends called him David Campbell, a Scottish mechanical engineer with an extraordinary gift for solving impossible problems. Dave had spent years in the oil fields working with pipelines in brutal conditions. He understood pressure systems, metal fatigue, and the behavior of fluids under stress. But this challenge was unlike anything he'd faced. The English Channel was 70 miles of treacherous water at its widest crossing point. Depths varied wildly. Currents could tear steel cables like cotton thread. German patrols meant any construction activity had to remain completely invisible, and the entire system had to be operational within 18 months of approval. Dave sat in his workshop in Liverpool, surrounded by technical drawings and calculations, chain-smoking cigarettes as he worked through the night. The fundamental problem was the pipeline itself. Standard rigid steel pipes would crack under the immense pressure and constant movement. Ocean currents would bend them. Temperature changes would stress the metal to failure. They needed something flexible yet incredibly strong, something that could be manufactured quickly in wartime Britain. Dave proposed a revolutionary design, a flexible pipeline made from layers of steel wire, wrapped in a helix pattern around a lead core, then covered in protective casing. It could bend without breaking, withstand enormous pressure, and be produced in sections. His colleagues thought he'd lost his mind. It had never been done. But Dave built a prototype in his workshop and tested it relentlessly. He froze it, heated it, bent it, pressurized it to breaking point and beyond. The design held. It actually worked. When he presented his results to the PLUTO committee, there was stunned silence. Then approval. Dave's flexible pipeline would become the heart of Operation PLUTO. But designing it was one thing. Manufacturing it was an entirely different war. Britain in 1943 was a nation under siege. Its resources stretched impossibly thin. Steel was rationed. Factories worked around the clock building tanks and aircraft. Yet somehow Dave and his team had to produce thousands of miles of specialized pipeline. They commandeered facilities across Britain, from Glasgow to Southampton. Former textile mills were converted to wind the steel wire in precise helical patterns. Rubber factories produced the outer protective casing using scarce raw materials. Dave personally supervised the production lines, troubleshooting problems in real time. Workers called him the Ghost because he appeared everywhere, day and night, checking quality. He understood that a single flaw could doom the entire mission and countless lives. The pipeline came in two main varieties, each with its own engineering challenges. The first type was Hamel, named after the Anglo-Iranian engineer and a British company. 3 inches in diameter, it could deliver fuel at pressures up to 1,500 psi. The second was Hayes, a larger 4-inch pipe for higher volume transport. Both designs incorporated Dave's flexible wire wound construction. Testing revealed unexpected problems that Dave solved with characteristic ingenuity. The lead core sometimes separated from the steel wire under extreme bending. Dave redesigned the bonding process, using a specialized adhesive compound he formulated. Saltwater corrosion threatened to eat through the protective casing within months. He developed a multi-layer protection system using tar, rubber, and steel armor. By summer 1943, production was reaching 10 miles of pipeline per day, an industrial achievement that rivaled any military manufacturing effort of the war. But making the pipeline was only half the battle. Now they had to deploy it. And for that, they needed to solve a problem that had never been tackled before. How do you lay 70 miles of pipeline on the bottom of the English Channel? Traditional pipe-laying ships were designed for calm, shallow waters and short distances. The Channel was none of those things, and German reconnaissance made surface work lethal. The PLUTO team needed a method to lay miles of pipe quickly and covertly. Dave proposed using massive floating drums to spool and deploy the pipeline. These drums, nicknamed conundrums, would be engineering marvels in their own right. Each drum stood 40 feet tall and could hold up to 80 miles of pipeline. The pipe would be wound onto the drum in a perfect spiral at the manufacturing facility. Then the entire drum would be towed across the channel by tugboats. As the tug moved forward, the drum would rotate, feeding pipeline to the seabed. Simple in concept, monumentally difficult in execution. The drums had to be perfectly balanced or they'd capsize in the channel's rough seas. The pipe had to unspool at exactly the right rate to avoid kinking or breaking, and the entire operation had to work the first time, under combat conditions. Dave spent months refining the drum design, calculating rotation speeds and tensions. He built scale models and tested them in Liverpool's Albert Dock. Local children watched in fascination as strange steel drums bobbed in the water. They had no idea they were witnessing one of the war's most crucial innovations. By December 1943, the first full-scale conundrum was ready for testing. A 40-foot steel cylinder painted dull gray floating in a secret facility. Dave supervised as it was loaded with 10 miles of pipeline for trial runs. The test deployment in the Irish Sea revealed problems no one had anticipated. The drum's rotation created a vortex that threatened to pull it underwater. Dave added stabilizing fins and adjusted the winding pattern to reduce turbulence. The pipe sometimes twisted as it left the drum, creating weak points and potential leaks. He designed a guide system that controlled the pipe's path from drum to seabed. By spring 1944, the conundrums were operational and proven. Multiple drums were positioned at secret locations along England's southern coast. Disguised as marine equipment, hidden in plain sight from German spy planes. The pipelines were manufactured, the drums were ready. Now they needed the pumping stations to push fuel through the system. This challenge would require Dave to innovate yet again. Pumping fuel 70 miles through a 3-inch pipe on the ocean floor required enormous pressure, far beyond what any existing petroleum pumping station could deliver. Dave calculated they needed pressures exceeding 1,800 pounds per square inch. At those pressures, fuel behaved unpredictably, heating up and expanding dangerously. A rupture anywhere in the system would create a catastrophic explosion and fire. The pumping stations had to be built into England's coastline, heavily camouflaged. Dave worked with military engineers to construct massive concrete bunkers. From the outside, they looked like ordinary coastal defense installations. Inside, they housed some of the most advanced hydraulic equipment ever built. Multiple redundant pump systems, each capable of moving thousands of gallons per hour. Cooling systems to manage the heat generated by high-pressure fuel compression. Monitoring equipment to detect leaks or pressure drops anywhere in the pipeline. Dave personally tested every component, pushing each system beyond its rated limits. He understood that in war, equipment always operates under worse conditions than planned. The pumps had to work perfectly in rain, fog, underbombing, and during storms. Failure wasn't just an engineering problem. It meant soldiers dying for lack of fuel. One innovation Dave pioneered was an automatic pressure regulation system. If pressure dropped, indicating a leak or blockage, pumps would adjust automatically. This prevented cascading failures and allowed operators to isolate problem sections. He also designed the system to handle different fuel types without cross-contamination. Gasoline, diesel, and aviation fuel could all flow through the same pipeline safely. By May 1944, pumping stations were operational at Sandown on the Isle of Wight and at Dungeness in Kent, both locations chosen for their proximity to France. Storage tanks holding millions of gallons fed into Dave's pumping systems. Everything was ready, D-Day was approaching, but Dave knew the real test would come when they laid the pipeline under fire. In the first days of June 1944, southern England became an armed camp. Thousands of ships gathered in ports. Hundreds of thousands of troops prepared to embark. Operation Overlord, the invasion of Normandy, was about to begin. Dave and his team waited at the pumping stations, knowing their moment would come. But first, the infantry had to establish a beachhead secure enough for pipeline operations. On June 6th, as Allied forces stormed the beaches, Dave listened to reports. Heavy casualties at Omaha, success at Utah and Sword, progress at Golden Juno. The invasion was holding, but fuel was already becoming a critical concern. Ships shuttled jerry cans across the channel, a desperate and inadequate supply method. Every hour of delay meant Allied tanks sitting idle while German reinforcements arrived. PLUTO had to become operational as soon as humanly possible. The original plan called for waiting until French ports were captured and secured, but the intensity of fighting meant those ports might not be available for weeks. Allied commanders made a bold decision: lay pipeline directly to temporary beach facilities. This meant laying pipe through waters still contested by German naval forces. Past mines, through areas patrolled by U-boats and E-boats. Dave volunteered to accompany the first pipeline deployment operation himself. His superiors tried to dissuade him. He was too valuable to risk in combat. But Dave insisted. If problems arose during deployment, he needed to be there. No one else understood the system as thoroughly or could improvise solutions as quickly. On June 12th, the first conundrum drum was towed out of Southampton. Dave stood on the deck of the lead tugboat, watching the massive drum float behind them. It contained 70 miles of pipeline, wound perfectly over months of patient work. Everything his team had designed, built, and tested was about to face reality. The channel crossing began in fog, which provided cover, but it also meant they couldn't see threats until they were dangerously close. Dave stood at the rail, smoking cigarette after cigarette, eyes on the drum, watching for any sign of instability, any indication the system was failing. The drum turned smoothly, pipeline feeding into the channel. Behind them, a steel thread connected England to France, a lifeline that would fuel the liberation of Europe. If it survived the next 12 hours, 4 hours into the crossing, German coastal artillery spotted the unusual convoy. Shells began falling, throwing up towers of water uncomfortably close to the tugboats. The convoy couldn't speed up without risking damage to the pipeline deployment. Dave watched as the conundrum drum continued its steady rotation, oblivious to danger. A near miss rocked the tug violently. Crew members took cover, but Dave remained at his station, monitoring the pipeline's feed rate and tension. Any disruption to the drum's rotation could kink the pipe or cause it to snap. Allied destroyers laid down suppressing fire, silencing some of the German guns. The convoy pressed forward, trailing its invisible cargo on the channel floor. Then new danger emerged, a periscope breaking the surface 300 yards away. A German U-boat had detected the unusual surface activity and moved to investigate. If it attacked the conundrum, 70 miles of pipeline would be lost, months of work destroyed, and PLUTO potentially compromised as a strategic asset. Allied escort vessels launched depth charges, forcing the U-boat to dive deep and retreat. The pipeline deployment continued uninterrupted. As they approached the French coast, Dave saw the beaches of Normandy for the first time, still scarred from combat, littered with wreckage but firmly in Allied hands. Engineers had prepared a receiving station, a temporary facility protected by sandbags. The final section of pipeline was manhandled from the surf to the connection point. Dave supervised the coupling personally, checking every seal and valve. 14 hours after leaving Southampton, the connection was complete. Now came the moment of truth, pumping fuel through the system for the first time. Dave radioed back to England. The pumping station operators began their sequence. Pressure built slowly, carefully, watching for any sign of failure. 500 psi, 1,000 psi, 1,500 psi. Somewhere beneath the English Channel, fuel was flowing through Dave's pipeline. At the French receiving station, they watched the gauge that would confirm success. Seconds ticked by, then minutes. Had the pipeline failed somewhere mid-channel? Suddenly, the pressure gauge at the French end jumped. Fuel was flowing. PLUTO was operational. The engineers erupted in cheers. Some wept openly. Dave allowed himself a brief smile before turning back to his monitoring equipment. The system was working, but they needed to verify stability over hours and days. Verify it could maintain flow through storms, pressure changes, and temperature shifts. The first pipeline was just the beginning. They would need many more. With the first pipeline proven operational, the PLUTO team began an aggressive expansion. Multiple pipelines were laid in quick succession, creating redundancy and increased capacity. From Dungeness to Ambleteuse near Calais, as Allied forces captured more French coast. From Shanklin on the Isle of Wight to Cherbourg once that vital port was secured. Each deployment brought new challenges that Dave and his team had to overcome in real time. One pipeline snagged on a sunken wreck, threatening to tear as tension mounted. Dave calculated a new deployment path on the spot, rerouting around the obstacle. Another suffered pressure fluctuations due to unexpected temperature variations in the channel. He modified the pumping protocols to compensate, maintaining steady flow. A severe storm in July threatened to rip several pipelines from their seabed anchoring. Dave designed emergency stabilization procedures that crews executed during the gale. Not a single pipeline was lost, though several required maintenance afterward. By August 1944, PLUTO was pumping over 1 million gallons of fuel per day. The system that military experts had declared impossible was now feeding Allied armies. Tanks rolled across France with their fuel tanks full, never pausing for supply delays. Aircraft flew continuous missions, their aviation fuel flowing steadily from England. The German army, by contrast, was crippled by fuel shortages and disrupted supply lines. Dave rarely slept during these months, moving between pumping stations and deployment sites, troubleshooting problems, training operators, optimizing flow rates and pressure settings. His colleagues noticed he'd aged years and months, the stress etched deep in his face. But whenever someone suggested he rest, Dave would simply light another cigarette and return to his calculations, always finding ways to improve system performance. The logistics were staggering, coordinating fuel supply from British refineries, managing storage facilities on both sides of the channel to maintain consistent flow, scheduling maintenance windows without disrupting the Army's relentless advance. Dave developed a rotation system where pipelines could be taken offline for inspection, while others compensated, ensuring continuous fuel supply without interruption. He also pioneered remote monitoring techniques, using pressure sensors and flow meters to detect problems anywhere in the 70-mile pipeline before they became critical. These innovations would later revolutionize civilian pipeline operations worldwide. But in 1944, they were simply necessary tools to win the war. Operation Pluto's success came at a cost that was rarely discussed in official reports. The men and women who built and operated the system worked under crushing pressure. Factory workers manufacturing pipeline often worked 18-hour shifts without breaks. Several died in industrial accidents, their names never appearing on war casualty lists. Pumping station operators suffered hearing damage from the constant roar of machinery. Some developed respiratory problems from fuel vapor exposure in the confined stations. The crews who laid pipeline under fire faced constant danger from enemy action. 2 tugboats were sunk by German patrol boats, with significant loss of life. A pumping station at Dungeness was hit by a V-1 flying bomb in August, killing 3 operators and severely wounding 5 others before backup systems engaged. Dave attended the funerals when he could, though operational demands rarely permitted it. He carried the weight of every casualty personally, knowing each loss was in service of a system he had designed and championed. His own health deteriorated under the relentless pace and constant stress. He developed stomach ulcers, lost significant weight, and suffered from chronic insomnia. Medical officers ordered him to rest multiple times, orders he consistently ignored. In September, he collapsed at a pumping station and was hospitalized for exhaustion. He discharged himself after 2 days, claiming the system couldn't operate without him. His assistant, a young engineer named Margaret Thornton, finally confronted him. She told him that killing himself wouldn't help the war effort or honor the dead, that he'd trained them well enough to maintain operations if he took proper rest. Dave listened, perhaps for the first time allowing himself to acknowledge his limits. He agreed to delegate more operational control and maintain a more sustainable schedule, though he never truly stepped back from his obsessive attention to every detail. The war had changed everyone involved in PLUTO, marking them in ways visible and invisible, but they continued because they understood what was at stake. Every gallon of fuel they pumped meant Allied soldiers one step closer to victory. Every day the system operated meant German defeat came faster. That knowledge sustained them through the darkest moments. In October 1944, disaster nearly struck when a pipeline developed a catastrophic leak. Pressure sensors detected a massive drop somewhere in the middle of the channel crossing. Thousands of gallons of fuel were pouring into the ocean every hour from the rupture, an environmental catastrophe and a strategic crisis all at once. Dave mobilized a repair team, though the challenge seemed almost insurmountable. The leak was 40 feet underwater in the middle of the channel's strongest currents. Divers would have to locate the rupture, assess the damage, and somehow repair it, all while working in near-zero visibility and fighting current that could sweep them away. The first dive team found the rupture after 3 hours of searching in the murky water. A section of pipeline had been damaged, possibly by a piece of unexploded ordnance. The protective casing was torn open, and the inner layers were compromised along 10 feet. Standard procedure would be to abandon the pipeline and lay a new one. But Dave calculated they couldn't afford to lose this pipeline's capacity. Allied forces were preparing for a major offensive, and every pipeline mattered. He designed an emergency repair procedure that had never been attempted underwater. A sleeve system that would be clamped around the damaged section and sealed with compound, then reinforced with steel bands and covered with protective material against corrosion. The work required divers to make multiple descents in challenging conditions. Each dive was limited to 15 minutes before hypothermia became life-threatening. Dave coordinated from a surface vessel, tracking progress and adjusting procedures. After 16 hours of continuous effort, the repair was complete. Pumps were restarted slowly. Pressure built gradually, everyone holding their breath. The repair held. Pressure stabilized at operational levels. The pipeline that should have been abandoned was back in service within 24 hours. This repair technique became standard procedure for future pipeline maintenance. Another of Dave's innovations that would outlive the war itself. But the incident highlighted the system's vulnerability and the constant threat of failure. Every pipeline was operating at the edge of its design limits under wartime conditions. The miracle wasn't that problems occurred, but that they occurred so rarely, a testament to Dave's engineering excellence and the dedication of his team. As 1944 gave way to 1945, Pluto faced its harshest test, winter in the Channel. Temperatures plunged, seas grew violent, and ice formed on equipment and vessels. Fuel viscosity increased in the cold, requiring higher pressures to maintain flow rates. Pumping stations consumed more power fighting against the thickened fuel. Dave implemented heating systems at critical points to keep fuel flowing properly. The pipelines themselves had to be monitored constantly for cold-induced brittleness. Metal that was flexible in summer could crack catastrophically in winter cold. Several pipelines required pressure reductions to prevent stress fractures during freezes. This reduced capacity exactly when Allied armies needed maximum fuel delivery. The Battle of the Bulge in December 1944 created desperate fuel demands. German forces had launched a massive surprise offensive through the Ardennes forest. Allied units were surrounded, cut off, and desperately short of fuel for tanks and vehicles. Pluto's pipelines became even more critical as winter storms grounded supply aircraft. Dave personally supervised operations around the clock during this crisis period, pushing the system to its absolute limits while staying just shy of catastrophic failure. Pumping station operators worked in brutal cold, maintaining equipment that iced over. Maintenance crews went out in storms to repair problems that couldn't wait for better weather. The system delivered, pumping fuel that helped blunt the German offensive. By January, the bulge was contained and Allied forces resumed their eastward advance. Pluto had survived winter, proving the system could operate year-round under any conditions. Dave allowed himself to believe that victory was now truly inevitable. The German war machine was running dry while Allied armies had fuel to spare. Technology and engineering were proving as decisive as courage and firepower. But the war wasn't over, and Pluto's mission continued without pause. Spring 1945 brought the final Allied drive into the heart of Nazi Germany. Armies crossed the Rhine, surrounded the Ruhr, and raced toward Berlin. Every advance required fuel in quantities that boggled the imagination. Pluto's network had expanded to 17 separate pipelines by this point. Some connected England to France, others linked captured French ports to Belgium. The entire system was pumping nearly 2 million gallons of fuel per day. An engineering achievement that would have seemed impossible just 3 years earlier. Dave had become something of a legend among Allied engineering corps. Stories circulated about the Scottish engineer who could fix anything under any conditions, who had designed a system that worked when every expert said it couldn't, who cared more about the mission than his own health, comfort, or recognition. But Dave himself remained focused solely on maintaining operations. He knew that every day of reliable fuel delivery shortened the war, saved Allied lives, and hastened the liberation of concentration camps. That knowledge drove him forward even as exhaustion became his constant companion. In April, as Allied forces closed in on Berlin from all directions, Dave received word that several pipelines would soon be decommissioned. Allied forces had captured enough ports and territory to establish conventional supply lines. Pluto had done its job. The emergency was over. On May 8, 1945, Germany surrendered unconditionally. The war in Europe was over. Victory had come. Dave was at a pumping station when the announcement came over the radio. Operators cheered, embraced, wept with relief and joy. Dave simply stood quietly, watching the pressure gauges continue their steady readings. The pipelines didn't know the war was over. They kept pumping fuel, doing the job they were designed to do, as they had every day since deployment. Someone handed him a glass of whiskey for a victory toast. He raised it silently to all those who hadn't lived to see this day. The workers who died in factories, the sailors lost at sea, the operators killed in air raids, the soldiers PLUTO had helped keep fighting. Then he drank and returned to his monitoring station. There would be time for celebration later. Right now, there was still work to do. In the months following Germany's surrender, the full scope of Operation PLUTO became public. Newspapers published stories about the secret pipeline that had fueled the liberation. The public was fascinated by this hidden technological marvel. Military analysts calculated that PLUTO had delivered over 180 million gallons of fuel, equivalent to the cargo of thousands of tanker ships that never had to cross the channel. The system had operated with remarkable reliability, averaging over 95% uptime, even accounting for maintenance, repairs, and the occasional pipeline failure. General Eisenhower himself acknowledged PLUTO's contribution to Allied victory, stating that the pipeline had been instrumental in maintaining the momentum of advance. Without it, the war might have dragged on months longer with thousands more casualties. Arthur Hartley, who had first proposed the concept, received public recognition. Lord Mountbatten was praised for championing the project despite skepticism. But Dave Campbell, the engineer who had made it all work, remained largely unknown. He preferred it that way, uncomfortable with attention and praise. When reporters sought him out, he directed them to his team members instead, insisting that PLUTO was a collective achievement, not the work of any individual. He was offered prestigious awards and honors, most of which he declined. He accepted only those that could be shared with his entire engineering team. His colleagues from the war years would later describe Dave as brilliant but humble, a man who measured success not in accolades but in problems solved, in systems that worked when they were needed most. The British government eventually awarded him an OBE, Order of the British Empire, for services to military engineering, though the citation was deliberately vague. Much of PLUTO's technical details remained classified for years after the war. Dave attended the ceremony, shook hands with dignitaries, then returned to civilian work. He never spoke publicly about his wartime service unless directly asked. And even then, he focused on the technical challenges rather than his own contributions. To him, PLUTO was simply a job that had needed doing, and he had done it to the best of his considerable ability. The technological innovations developed for Operation PLUTO didn't end with the war. Dave's flexible pipeline design revolutionized the petroleum industry worldwide. Post-war, his wire-wound construction method was adapted for civilian applications. Undersea pipelines began connecting offshore oil platforms to mainland facilities. His pressure monitoring and remote sensing systems became industry standard, preventing countless leaks and failures in petroleum infrastructure globally. The underwater repair techniques developed during that October 1944 crisis became the foundation for modern submarine pipeline maintenance procedures. Even the conundrum drums found post-war applications. The concept of large-scale cable and pipeline spooling systems was adapted for laying telecommunications cables across oceans and oil pipelines in remote regions. Dave himself returned to the petroleum industry after the war, working as a consulting engineer for major pipeline projects around the world. He helped design pipeline networks in the Middle East, Southeast Asia, and South America, always insisting on the highest safety and reliability standards. His wartime experience had taught him that engineering failures cost lives. Even in peacetime, poorly designed systems could kill workers and devastate communities. He became known as an engineer who would never compromise on safety, even if it meant walking away from lucrative contracts. Young engineers sought him out for mentorship, drawn by his reputation for excellence. Dave taught them not just technical skills but professional ethics, the responsibility that comes with designing systems that people depend on. Many of his mentees went on to distinguished careers in engineering, carrying forward the principles Dave had demonstrated during Operation PLUTO. Innovation driven by necessity, quality that never compromises, humility in success and perseverance through failure. These became the hallmarks of what colleagues called the PLUTO standard. By late 1945, most of Pluto's pipelines were being systematically shut down. The emergency conditions that had necessitated their construction no longer existed. European ports were functioning again, and conventional fuel supply chains were restored. The massive pumping stations were decommissioned, their equipment sold or repurposed. The conundrum drums were cut up for scrap metal, their steel needed for reconstruction. The pipelines themselves presented a unique challenge in decommissioning. Attempting to recover them from the channel floor would be expensive and difficult. Most were simply flushed clean, sealed at both ends and left in place, where they remain to this day buried in channel sediment, silent testament to an extraordinary engineering achievement. Dave supervised much of the decommissioning work with the same attention to detail he had brought to construction and operation years earlier. He insisted that all fuel residue be properly cleaned from the systems, that environmental contamination be minimized during the shutdown process, that detailed documentation be preserved for future engineers who might learn from PLUTO. It was bittersweet work, dismantling a system that had performed so magnificently. But Dave understood that PLUTO had served its purpose and served it well. The pipelines had helped win the war, and that was all they were ever meant to do. As the last pumping station was shut down in December 1945, Dave gathered his core team for a final meeting at the site. No speeches were made, no formal ceremonies conducted. They simply stood together in silence, listening to the pumps wind down. The machinery that had run continuously for 18 months finally going quiet. Then they shook hands, said their goodbyes, and went their separate ways. Back to civilian lives, carrying memories of what they'd accomplished together. The impossible pipeline that had helped free a continent. For several years after the war, Operation PLUTO remained partially classified. The British government wanted to protect certain technical innovations from foreign powers, especially the flexible pipeline design and high-pressure pumping techniques. But by the early 1950s, most technical details were declassified. Engineers and historians could finally study PLUTO comprehensively. What emerged was a fuller picture of the project's scope and significance. The planning had involved hundreds of scientists, engineers, and military strategists. The construction had employed thousands of workers across Britain. The operation had required coordination between multiple military branches and civilian agencies. Yet it had remained virtually unknown to the public during the war itself. A remarkable achievement in operational security. Dave was approached by several authors and historians seeking interviews. He granted only a few, preferring to let the technical documentation speak for itself. When he did speak, he focused on the collaborative nature of the project, the contributions of workers whose names would never appear in history books, the sacrifices made by families who didn't understand why their loved ones worked such hours. In one rare interview in 1952, Dave was asked about his greatest achievement. He paused for a long moment before responding with characteristic humility. "We built something that worked when it needed to work, that's all." The real achievement belonged to the soldiers who used that fuel to liberate Europe. "We just made sure they didn't run out of petrol." His interviewer pressed him about the technical brilliance of the flexible pipeline design. Dave shrugged it off. It was the obvious solution once you understood the constraints. Any competent engineer would have arrived at something similar. This was untrue, of course. Dave's design was revolutionary, but he genuinely believed that he'd simply done his job, that the war had required a pipeline and he'd built one. This humility endeared him to colleagues but frustrated historians, who recognized that Dave's contributions deserved far greater recognition. Dave Campbell continued working as a consulting engineer well into his 60s. His reputation had spread throughout the petroleum industry worldwide. Companies sought his expertise for the most challenging pipeline projects. He never lost the work ethic that had defined his wartime service. Still putting in long hours, still obsessing over every technical detail, still chain-smoking cigarettes while poring over engineering drawings. He married in 1948 to a woman named Elizabeth who had worked as a code breaker. She understood the peculiar intensity of wartime service and its lasting effects. They had 2 children, both of whom would eventually become engineers themselves, though Dave never pressured them toward that career path. In his personal life, Dave was quiet and reserved, preferring small gatherings. To large social events, he rarely spoke about his war service at home. His children didn't learn the full extent of his contributions until they were adults. He suffered from what we'd now recognize as post-traumatic stress. Nightmares about pipeline failures, about fuel running out at critical moments, about the workers who died in accidents during construction. Elizabeth helped him through these difficult periods with patience and understanding. Dave found solace in continued engineering work, in solving new problems. Each successful project was a small affirmation that his skills still mattered. In 1964, on the 20th anniversary of D-Day, Dave was invited to a commemoration ceremony in Normandy. He initially declined, uncomfortable with public recognition, but Elizabeth convinced him to attend, arguing that he owed it to his team. To represent all those who had worked on Pluto, standing on those beaches 2 decades after the invasion, Dave was overcome with emotion for one of the few times in his adult life. Seeing the peaceful coastline, the memorials to the fallen, the French families living normal lives thanks to the liberation, it brought home the meaning of all those sleepless nights and impossible challenges. Pluto hadn't just been an engineering project. It had been a contribution to human freedom. Chapter 18. Engineering Philosophy. Throughout his post-war career, Dave developed a philosophy of engineering. Based on the lessons learned during Operation Pluto, he believed that engineering wasn't just about technical excellence, but about understanding the human context in which systems operate. Designed for the worst conditions, not the average ones, he would tell students. Your system will face storms, failures, and human error. It needs to be robust enough to survive all of that. He emphasized redundancy and fail-safe mechanisms in all his designs. Multiple backup systems, automatic shutdowns, pressure relief valves. Pluto had taught him that systems operating at their limits needed protection. Dave also believed deeply in the importance of maintenance and monitoring. A system is only as good as the people who maintain it, he often said. He designed his post-war projects with maintenance accessibility as a priority. Not just theoretical maintainability, but practical access for real workers, with real tools and real-world conditions. He was deeply opposed to unnecessary complexity in design. Elegant solutions are usually simple solutions, he wrote in a technical paper. Complexity creates failure points, simplicity creates reliability. This didn't mean his designs were unsophisticated. Rather, he had a gift for reducing complex problems to their essential elements, then solving those elements in the most straightforward way possible. Perhaps most importantly, Dave believed in the ethical responsibility of engineers. When you design a bridge, you're responsible for every person who crosses it. When you design a pipeline, you're responsible for every community it passes through. That responsibility never ends, and you must never forget it. He refused to work on projects where safety was compromised for profit, where environmental considerations were ignored, or where proper maintenance budgets were not allocated. This stance cost him some lucrative contracts over the years, but earned him respect throughout the engineering community. In 1974, 30 years after D-Day, a reunion was organized for those who had worked on Operation Pluto during the war. It was held at a hotel in Southampton, near where the first conundrum had been deployed. Dave attended reluctantly, still uncomfortable with gatherings focused on past achievements. But he was curious to see old colleagues, to learn what paths their lives had taken. Over 100 people gathered: engineers, pump operators, factory workers, military personnel who had coordinated the deployment operations. They were older now, grayer, but the bonds formed under wartime pressure remained strong. Stories were shared late into the night, memories that had been private for decades, the terror of laying pipeline under German artillery fire, the exhaustion of 18-hour shifts in freezing pumping stations, the pride of seeing the system work despite all predictions of failure. One elderly woman approached Dave with tears in her eyes. She had worked in a Liverpool factory winding wire for the pipeline. She told him she'd never known if her work had mattered, if those endless hours had contributed to anything meaningful. Dave took her hands and told her that without her work, without every worker, the pipeline would never have existed and the war might have lasted longer, that her contribution had mattered more than she could possibly know. The woman embraced him, sobbing, finally receiving the acknowledgement she had waited 3 decades to hear. That moment crystallized something for Dave: the importance of recognizing every contribution, no matter how small it seemed. Great achievements were never the work of individuals. They were the sum of thousands of people doing their best. At the reunion's conclusion, Dave gave a brief speech, the only public address he ever made about Operation Pluto. He spoke about the ordinary people who had done extraordinary things, about the power of collective effort focused on a common goal, about the privilege of having served alongside such dedicated individuals. When he finished, there wasn't a dry eye in the room. Dave Campbell retired from active engineering work in 1978, though he continued consulting on particularly challenging problems until the mid-1980s. His health had declined, decades of stress and cigarette smoking taking their toll. But his mind remained sharp, his passion for engineering undiminished. He spent his retirement years writing technical papers and mentoring young engineers, passing on the knowledge accumulated over a remarkable career. He and Elizabeth traveled, visiting places they'd never had time to see. During one trip to France, they visited the Normandy beaches again. Dave walked along the coastline, imagining where the pipeline had come ashore. How different these peaceful beaches looked from the war-torn shores of 1944. He was approached by a young French man who had seen them at the memorial. The man's grandfather had been liberated from a Nazi labor camp by Allied forces whose advance had been fueled by PLUTO. He thanked Dave with a passion that transcended language barriers. Dave accepted the thanks with his characteristic humility, but privately he was profoundly moved by this tangible connection. Between his wartime work and a life saved, a family continued. In 1989, Dave Campbell passed away at the age of 78. His obituary in the Times mentioned Operation PLUTO prominently, but Dave would have preferred it focus on his family and his post-war work, the things he'd accomplished in peace, not just in war. His funeral was attended by hundreds, engineers from around the world, former colleagues from PLUTO, now elderly themselves, students he'd mentored who had gone on to distinguished careers. They remembered not just his technical brilliance, but his integrity, his humility, his unwavering commitment to doing things right. One former student spoke at the service about Dave's influence. He taught us that engineering isn't just about solving technical problems. It's about serving humanity, about taking responsibility for our creations, about never compromising on safety or quality. He showed us what it means to be not just a good engineer, but a good human being. Epilogue. Remembering PLUTO. Today, Operation PLUTO is remembered as one of World War II's most ingenious achievements, a triumph of engineering that helped secure Allied victory in Europe. The pipelines still lie on the Channel floor, slowly being covered by sediment, physical remnants of an extraordinary undertaking. Museums in Britain and France display sections of the pipeline, pieces of the conundrum drums, photographs of the pumping stations. These artifacts help preserve the memory of what was accomplished. Engineering schools use PLUTO as a case study, teaching students about innovation under constraints, about rapid prototyping, about the importance of reliability, and about collaborative problem solving. The story of Dave Campbell and his team illustrates how engineering excellence can change the course of history, not through weapons or destruction, but through logistics and infrastructure. By solving the unglamorous but critical problem of fuel supply, modern undersea pipelines carrying oil and gas across oceans owe a debt to the innovations pioneered for Operation PLUTO. The flexible pipeline design, the deployment methods, the monitoring systems, all have evolved from that wartime necessity into standard practice. But perhaps PLUTO's greatest legacy isn't technical. It's the example of what can be achieved when brilliant people work together toward a common goal with dedication and purpose, when they refuse to accept that something is impossible and instead figure out how to make it work. Dave Campbell embodied this spirit, a quiet, humble man who never sought glory, but whose contributions helped free a continent, whose innovations continue to benefit humanity decades after his death, who showed that true heroism isn't always found on battlefields. Sometimes it's found in workshops and pumping stations, in slide rules and technical drawings, in the patient, meticulous work of engineers solving impossible problems. Operation PLUTO stands as testament to the power of human ingenuity and the difference that dedicated individuals can make when faced with challenges that matter. The pipeline under the ocean became a lifeline for liberation, and its story deserves to be remembered. As long as we value courage, innovation, and service, Operation PLUTO, the secret weapon that helped win the war, 1 gallon at a time.